Good morning, sir.
Good morning, sir.
Good day, Engineer Manatad, Engineer Apat, Engineer Soquiño, and Engineer Berioso.
Good day, Principal.
Sir. Good day, sir. It's been a long time.
Okay. My dear alumni students, I see that you've been finally become thriving engineers to this day. The institution is honored that we've been part of your journey to success. I would like to ask you a small favor to impart your knowledge about certain topics that are related to your profession. At the moment, to our dear students who would like to take up in the same field as you guys were.
Of course, sir.
I agree, sir.
Okay, thank you very much, and I am sure the students will be so happy knowing that professional electric engineers will be teaching them. Once again, thank you so much for your cooperation. Me and the students will be waiting for the video that you will send.
No problem, sir. Thank you so much.
Okay, once again, good day, engineers.
Good day, sir. Thank you.
Thank you, sir.
So hello everyone, my name is Marlyz Beane S. Apat, a graduate from Bachelor of Science in Electrical Engineering. I am currently working in a hospital, and your dear principal contacted us, me and my friends. So he contacted us so that we can share to you guys some topics and lessons that you will surely encounter if you take this kind of field. So I hope in the end we can share you some knowledge and you will learn something from us, and I hope to everyone to have a great day. So for today's topic, I'm gonna teach you on how to solve the capacitors in series. When capacitors are connected one after another, they are said to be in series. For capacitors in series, the total capacitors can be found by adding the reciprocals of the individual capacitances and taking the reciprocal of the sum. If capacitors are connected one after the other, in this way we call them capacitors hooked up in series. So here, we're gonna use 3 capacitors. On the left, we have the battery, and let's say that the battery's voltage is 50 volts. And here we have the capacitors, capacitor 1, 2, and 3. For capacitor 1 has the capacitance of 2 farads, C2 has 3 farads, and capacitor 3 has 5 farads. So what is the equivalent capacitance in this circuit? That's the first thing we'll look for. A simple way to find the equivalent capacitance in a series circuit is going to be equivalent capacitance equals 1 over C1 plus 1 over C2 plus 1 over C3 minus 1. And now we'll have this equals 1 over C2. The 2, we got it from the capacitor's capacitance of C1, C2, C3's farads. So now we'll have this 1 over 2 plus 1 over 3 plus 1 over 5. Now solve it so that we can have the equivalent capacitance, and it is about 0.9677 farads. Now, with this information, how can we find the voltage across each of the capacitors? Sometimes you may need to find the voltage of just one of the capacitor, and with that, you're going to find the potential energy is stored in the capacitor. Now, let's focus on finding the voltage of each. So once you have the equivalent capacitance, which is this, the next thing you do is to calculate the charge. In calculating the charge, we have Q equals equivalent capacitance voltage. In a series circuit, the voltages across each capacitor will be different if the capacitance is different. In the series circuit, the charge stored on each capacitor is the same. So once we find Q, this Q will be the same as Q1, Q2, and Q3. They all equal to other. So now, let's find Q. Q is equals to the equivalent capacitance, which is 0.9677 times the total voltage. So we have 50 volts. So now we solve it and we'll get the total charge, which is 48.39. So now let's find the V1, V2, and the V3. The V1, it is going to be Q1 over C1. So we'll take the equivalent, the total charge, which is 48.39 over C1, which is 2, and it is equals to 24.2 volts. Now in C2, the C2 is gonna be Q2 over C2. Q1 and 2 is the same value. So we have 48.39 over 3, and it is equals to 16.1 volts. Lastly, to find C3 is gonna be Q3 over C3. So in that, we have Q3, it's going to be 48.39, and C3 is going to be 5. So 48.39 over 5. And it is equals to 9.7 volts. Now, before I forgot, these volts are the voltage across C1, C2, and C3. So the voltage across of C1 is 24.2. The voltage across of C2 is, we have 16.1 volts. And lastly, we have the voltage across of C3 is 9.7 volts. Notice that the total voltage is V1 plus V2 plus V3. So V1 is 24.2, V2 is 16.1, and V3 is 9.7. Now, we need to add these values. So, in order to get 50 volts, which is equivalent to our battery. That's how you know if your answer is correct. It has to agree with one another. The sum of these three values has to equal the battery's voltage. So the sum of these three values is equivalent to the battery's voltage. So we can see that the sum of these three values is equivalent to 50 voltage, which is similar to the battery's voltage in here. Lastly, let's calculate the potential voltage of C2. So C2 is going to be, in here, we have 1/2 and is equals to CV squared. So 1/2. This capacitance, we have 3 farads, and the total voltage of C2 is 16.1 squared. So we need to solve it, and in order to get the value, solve it, and you'll get the equivalent answer of 388.8 joules. So thank you for listening, and I hope you learn a lot from today's topic.
Hello everyone, my name is Joerenzer and Manatad. I am an electrical engineer. Right now, I currently work at a hospital. The other day, your principal reached out to me and my friends and asked us if we can spare some time to teach some students certain topics. Students who will be soon tackling the same field as we are. The topic that was assigned to me by your principal was parallel capacitor. In this discussion, I will tell you all I know about parallel capacitor. And now let us start our short discussion. I hope that you will learn something from this and you can use your knowledge in the near future to do good things. This is our problem. As you can see, we have a battery attached to 2 capacitors in parallel. We have a 10 volts battery. For our first capacitor, we have 100 microfarads. Our second capacitor has a value of 200 microfarads. What is the equivalent capacitance of this circuit? For parallel circuits, the equivalent capacitance is simply the sum of all the capacitors connected in parallel. Let me show you. Equals the first capacitor plus the second capacitor. The value of our first capacitor, as you can see, is 100 microfarads. So, (100) microfarads plus the value of our second capacitor, which is 200 microfarads, plus 200 microfarads. 100 plus 200 is equals to 300 microfarads. And this is our equivalent capacitance in this circuit. Now, how much charge is stored in C1? To calculate the charge, we need Q1 is equal to C1 times V1. So you need to know the voltage across C1. In a parallel circuit, the voltage across every element that's parallel to one another is the same. C is connected directly across the battery. As you can see, C1 is connected directly across the battery. So it has a voltage of 10 volts. Yeah, 10 volts when it's fully charged. And the same is true for C2 as well. 10 volts. They will all have the same voltage. So V1 is 10 and V2 is 10. And so now we will calculate Q1. You will need a calculator. And C1 is equal to 100. And 100 times 10 minus 6 The value of our V1 is 10 volts. So 10 times 10. And now, use a calculator. And our correct answer will be 0.001. And this will be our Q1. And so, this is the electric charge of Q1, 0.001. And now, let us proceed to C2. What is the electric charge stored in C2? We can use this equation. Q2 is equal to C2 times V2. The value of our C2 is 200. So 200 times 10 minus 6. The value of our V2 is 10 volts times 10. And now we will use a calculator. And the correct answer is 0.002 Q2. 0.002 is the electric charge of Q2. And now let's look for the total charge stored in this network. We will use the equation Qt is equal to Q1 plus Q2. The value of our Q1 is 0.001 plus the value of our Q2, 0.002. Our final answer would be 0.003 QT. 0.003 is the total charge in this network. Now, how can we calculate the energy stored in C1? What is the electric potential energy stored in a capacitor? One equation that we can use is this one. Equals 1/2 times CV squared. One half times the value of our capacitor, which is 100. 100 times 10 minus 6. And the value of our V1, which is 10 volts. Times 10 volts squared. And we need a calculator, and our final answer would be 0.005 joules. And 0.005 is the electric potential energy stored in C1, in our first capacitor. And that will be it in our discussion. Thank you for listening in our short discussion. First, I would like to congratulate the students who will soon become an electrical engineer themselves. And I hope that in the near future, you will become an excellent electrical engineer with a lot of achievements that your parents can be proud of.
and I would like to share to you a quote. All our dreams can come true if you have the courage to pursue them. I hope that you guys will remember this quote, because this quote will always remind you that if you have the courage, anything is possible. And by this quote, I hope that it can help you overcome all the obstacles that will come in your way. And that is all from me. See you soon, guys, as a fellow electrical engineer.
Hello everyone, my name is Graciela Klee D. I am an electrical engineer working at a hospital. I hope everyone here will have a very nice day. So, the other day, your principal reached out to me and my friends to discuss certain topics to some students who will be soon tackling the same field as we are. The topic that was assigned to me was about the series resistors. So for today's lesson, we're going to be taking a look at how we can solve the series resistors. And so our example problem here, basically what they want us is to be able to calculate the total resistance of the circuit, B, how much current flows from the battery, C, what is the voltage across each resistor, D, how much power is absorbed by each resistor, and D, how much power is delivered by the battery. Now we have a circuit where the resistors are connected in series, and the reason why they are connected in series is because there's only one path for the current to flow, and so the current that flows through each resistor is the same. The first thing we need to do is to calculate the total resistance of the circuit. In a series circuit, the total resistance of the circuit is the sum of R1 and R2. So it's going to be 4 plus 8, which is 12 ohms. Now part B, how much current flows from the battery? In a series circuit, there's only one current in a parallel circuit. In a parallel circuit, there's multiple current. So, the current that flows from the battery is going to be the voltage of the battery. Divided by the total resistance of the circuit, so it's 36 volts. Divided by 12 ohms. That is equal to 3 amps. Now part C. What is the voltage across each resistor? To calculate the voltage, we could use Ohm's law. It's equal to the current that flows through a resistor multiplied by the value of the resistance itself. So, to calculate V1 is going to be the current, which is 3 amps. Multiplied by the 8 ohm resistance, So the voltage across this resistor is 24 volts. To calculate the voltage across the second resistor, we'll call it V2. It's going to be the same current, 3 amps, multiplied by 4 ohms, and so that's going to be 12 volts. Notice that the voltage drop across the 4 resistor is half of the voltage drop across the 8 ohm resistor. As the resistance increases, the voltage drop across that increases, and these are known as voltage drops. Let's say if the electric potential here is 0 at this point, it's going to be 12 volts, and at this point is 36. So notice that the changes at this point have a higher potential than the charges at that point. And so what a resistor does is it consumes electrical energy from the charges. So as a charge flows through a resistor, it loses energy, and a resistor absorbs that energy, connects it into heat. Now the battery acts like a pump. When the charges go listen in that direction, that's really the current, by the way. In conventional current, the battery does work on the charges, and so it increases the electric potential of the charge from 0 to 36 volts. So make sure you understand this. The battery increases the electric potential of the charges. The resistors, they decrease the energy of the charges. And when you hear the word potential or electric potential, which is measured in volts, 1 volts, the energy per unit charge, so 1 joule is per coulomb. Because the battery increases the electrical potential or the energy per unit charge of the charges, I'm going to give it a positive voltage. Because it increases the energy of the charges, and this, I'm going to give it a negative voltage. Because resistors decrease the energy of a charge, and so if you add up 36 and negative 24 and negative 12, the voltage around a circuit add up to 0 is anything that increases the energy of a charge. You can assign positive voltage to it. It decreases the energy of the charge that following in the circuit, you can assign a negative voltage to it. So voltage is basically it's an energy per charge ratio. So it is related to energy, but it depends on the amount of charge that you're dealing with. Now notice that the voltage drops is equal to the voltage of the battery, and this is associated with Kirchhoff's voltage law, which states that the voltage around A closed circuit must add up to 0. Now let's go back to the problem. Let's move on to the part D. How much power is absorbed by each resistor? The best way to calculate power absorbed by the resistor, or there's multiple ways, but I like to use this equation. P is equal to I squared times R, so the current that flows through the resistor is 3 amps. And for resistors I, it has a value of 8 ohms, so it's 3 squared times 8, and so that resistor absorbs 72 watts of power. For the second resistor, P2 is going to be equal to I squared times R2. The current is still 3 amps, but the resistance is 4. So 3 squared is 9. 9 times 4 is 36. So this resistor consumes 36 watts or 36 joules every second. Now, let's calculate the power delivered by the battery. Power is also voltage times current. The voltage of the battery is 36 volts, and the current that leaves it as 3 amps. So, if we take 36 and multiply it by 3, we can see that the battery delivers 108 watts of power. Notice that the power delivered by the battery is equal to the sum of all the power that is absorbed by the resistor, by the two resistors. So 12 plus 36 is 108. So we can clearly see that the power delivered by the battery is equal to the power absorbed by all of the resistors. And this is due to the law of conservation of energy. The rate which the battery transfers energy to the circuit is equal to the rate of which all the elements in a circuit consume that energy. So now, let me give you another example. But instead of 2 resistors, we're going to use 3 resistors. In a series circuit, I want you to answer every question just like you did before. So, we're going to have the battery and we're gonna have 3 resistors. So, let's say this is 5 ohms resistor, a 10 ohm resistor, and a 20 ohm resistor. We're gonna say that the voltage is 175 volts. This is the positive terminal and a negative terminal. So first, what's the total resistance in a circuit? So the total resistance is going to be R1 plus R2 plus R3. So let's call this R1, R2, and R3. And R3 and R1 is 5, R2 is 10, and R3 is 20. So this adds up to 35 ohms. That's the total now. So let's move on to the part B. Let's calculate the total current that's going to be the voltage of the battery divided by the total resistance. So it's 175 volts. So first, What's the total resistance in a circuit? So the total resistance is going to be R1 plus R2 plus R3. So let's call this R1, R2, and R3. R1 is 5, R2 is 10, and 20, and R3 is 20. So this adds up to 35 ohms. That's the total. Now let's move on to the part B. Let's calculate the total current that's going to be the voltage of the battery divided by the total resistance. So it's 175 volts divided by 35 ohms, and so the current that flows in this circuit is equal to 5 amps. Let's move on to part C. So, what is the voltage across each resistor? So let's start with resistor I. So V1 is going to equal I times R1. So the current flowing through each resistor is 5 amps and R is 5 ohms. So the voltage across this element is 25 volts. Now, let's calculate the voltage across the second resistor. So, that's going to be I times R2. So, it still has the same current, 5 amps, but multiplied by 10 ohms. So, that's going to give us a voltage of 5 volts. So that's the value of V2. Now, let's do the same thing for the third resistor. So V3 is going to equal I times R3. So that's the current of 5 amps multiplied by 20 ohms. 5 times 20 is 100. So the voltage across this resistor is 100 volts now. Now, let's calculate the power delivered by the battery. So, I'm going to use this equation as well. So, the voltage of the battery is 175 volts. And the current of the battery, that is 5 amps. So, 175 times 5 is equal to 875. So that's how much power is delivered by this battery. And if we add up 500 plus 250 plus 125, notice that it adds up to 875. So everything is balanced in this circuit. And that's how you know if you did it correctly.
May the light of your glory never go dim. May the wisdom of God remain in you, and may the mighty doors be opened up for you. Congratulations on your graduations, and always keep in mind that the future belongs to those who believe in the beauty of their dreams.
Good morning, students. I am one of the representative electrical engineer. I am Engineer Alexandria A. Berioso. I work from the hospital alongside with Engineer Manatad, Engineer Soquiño, and Engineer Apat. So we are here today to teach you about a certain topic which is in your field, electrical engineering. So my assigned topic is all about parallel resistors. So consider the circuit shown below. Calculate the current flowing through each resistor. So let's call this resistor 1. And this one is resistor 2. So how can we determine how much current flows through the resistor? Well, we can use the Ohm's law. V is equal to I R. So the voltage of the battery, which is the voltage each resistor, that's going to equal the current flowing through the resistor times the resistor itself. So to calculate the current, it's going to be the voltage divided by the particular resistor. So we have 12 volts across the resistor, and if we divided it by 4 ohms, which is the resistor 1, that's going to give us the current of 3 amps. Flowing through that resistor. So that's for I1. So to calculate the I2, it's gonna be the voltage of the battery divided by R2, which is 6 ohms. So the current flowing through this resistor is 2 amps divided by 6 is 2. So keep in mind is 2 amps. 2 amps of current is flowing in this section of the wire. The current released by the battery is the sum of the currents flowing through each resistor, which is I1, I2. The current that flows through this segment has to be 5 amps. So it makes sense because at this junction, 2 went to the right and 3 amps went below. So the 2 amps current flows through this portion of the wire, then it meets up with the 3 amp current where it returns to the battery with a current of 5 amps. Now let's move on to part C. So how much power is absorbed by each resistor? So let's start with resistor 1. To calculate the power, we will use this formula. It's gonna be I1 squared times R1. So there's a current of 3 amps flowing through that resistor and a resistance of 4 ohms. So 3 squared is 9 times 4, that's 36. So 36 watts of power it's consumed by R1. Now let's proceed to R2. We are going to use the V squared divided by R. V squared divided by R. In a parallel circuit, the voltage of each resistor is the same, it's equal to the voltage of the battery. So we have 12 volts squared divided it by R2 is 6 ohms. So 12 divided by 6 is 2, and 2 times the other 12 is 24. So 24 watts is used up by this resistor. So 24 watts is used up by this resistor. Now let's calculate the power delivered from the battery. So we are going to use this equation. Voltage times the current, the battery is 12 volts and it delivers a current of 5 amps. 12 volts and 5 amps. So 12 times 5 is 60 watts. Now, as you can see, notice that the power delivered by the battery, which is 60, is equal to the power absorbed by all the resistors, which is 36 watts and 24 watts. So 36 watts and 24 watts is equal to 60 watts. And it has to be balanced due to the law of conservation energy. Now let's proceed to the last, which is calculate the total resistance in the circuit. So there's actually two ways in which we can do that. The first way is to take the voltage of the battery, divided by the total current in the circuit. So in the circuit, so we have 12-volt battery divided by 5 amps. So the total current of the circuit, so it's gonna be 12 divided by 5. So if you're going to divide 12 divided by 5, the equivalent resistance of this circuit is 2.4 ohms. So that's the first way. Now we can use the formula to confirm this answer. And for parallel circuit and 1 over RT is equal to 1 over 1 plus 1 over R2. So if you raise both sides to the negative 1, both sides to the negative 1, the total resistance becomes this. 1 over R1 plus 1 over R2. So if you raise both sides to the negative 1, the total resistance becomes this. 1 over R1. So R1 is 4. And plus 1 over R2. R2, which is 6. So 1/4 plus 1 over 6, that's 5 over 12. 5 over 12. So, which is 2.4 ohms. And so, this will give you the same answer. The first way and the second. So now you can have two ways in which you can calculate the total resistance of a parallel circuit. So thank you so much, students, for listening to my topic. I hope you learned something from it. And I would also like to thank the principal for inviting us, especially me, and for giving the chance to share my knowledge to our aspiring and future engineers. Be bold, be courageous, and be your best. Never give up and always chase your dreams. Laban, future engineer. Thank you so much and goodbye.